Okay, so here we have a tangent line and a function, and we want to find this value k such that this line is tangent to this function. So therefore we just need to determine the value k. In order for that to be true, this function must equal this function because it has to intersect x, so therefore the tangent line must equal the function at some value. Secondly, since this is tangent to this function, that means the slope of this line has to be the slope of this function at some point x. So the first thing we do is we're going to set the slope of this equal to the slope of this, or the derivative of the derivatives equal to each other. So the derivative of a line is just the slope, so that's -4. The derivative of the parabola, or the k, is just a constant, so that's nothing, so it's -2x. So x equals 2. So at 2, we know that the tangent line hits the function. So we just need to know what is the value of k. So now we have a tangent line and a function. So let's set the tangent line equal to the function. These two must equal each other in order for it to be a tangent line. At what number? At 2. So we just plug 2 in. So we -4 times 2 plus 7. 2 squared. So this is -8 plus 7 equals k minus 4. So -1 equals k minus 4. So our k value is 3. So derivatives equal to each other, functions equal to each other, use the corresponding x value, and then you get your value of k. Our next problem is we find the equation of the line that is tangent to this one and parallel to this line. So we have this other line over here that is not tangent to the curve, but we want to find the line that is tangent to the curve that's parallel to this line over here. So therefore, we want to know what is the slope of this line here, and then find that corresponding tangent to this point here. Well, this has a slope. That slope is equal to 3. And since we want to make a line that is tangent to this one here, we know that the slope of this has to equal the slope of that. The slope at some point of this has to equal 3. So therefore, slope and derivative are equivalent. So therefore, the derivative of f is equal to 3x squared. So that means at some x value, our derivative must equal 3. So x squared has to equal 1, so x equals plus or minus 1. So there's actually two tangent lines that are parallel to this line over here, namely at 1 and +1. So therefore, f of 1, we need to know the function value. So that is 1 cubed plus 2, which is equal to 3. And f of -1 is equal to -1 cubed plus 2, which is equal to 1. So we have an x value and a y value, and our slope is 3, because these tangent lines have to be parallel to this line over here. So therefore the slope has to be 3. So an x and a y and a slope, an x, a y, and another slope. So let's just create our two tangent lines. So our first one is going to be y minus 3 is equal to 3 times x minus 1. So we get y equals 3x minus 3 plus 3. So y equals 3x. And then our second tangent line is y minus 1 equals 3 times x plus 1. So we get y equals 3x plus 3 plus 1. So y is 3x plus 4. Last one is find the tangent line to the graph of y equals g of x. The tangent line is at the point -1, 4, passes through the point 3, 6. So it's tangent at -1, 4, so therefore -1, 4 is on g of x, so therefore g of -1 must equal to 4. And we just know some other random point that the tangent line goes through, and that point is 3, 6. So the first question is what is g of -4? Well, I just did that without knowing. G of -1 is equal to 4 because this point is on this function on the tangent line. So the tangent line hits this function at -1, 4. So therefore g of -1 must equal 4. The second thing is we want to know what g prime of -1 is. Well, we have 2 points that are on the tangent line. So if I have 2 points on a line, I can easily find out the slope, which is another way of saying what is the derivative value at -1. So g prime of -1 is going to be equal to 4 minus 6 negative 1 minus 3. So that's negative 2 over negative 4, which is 1/2. So our derivative at negative 1, or g prime of negative 1, is equal to 1/2, and our function value at negative 1 is equal to 4.